Well, it's finally a clear night. The moon's not in sight, and I'm looking at Alberio, a beautiful double star. One star is blue, the other is gold. Boy, it is striking in binoculars, and I want y'all to get out in your backyard and see it. Hello, everybody. I'm Stargazer Marquette. Thank you for being on Stay Star Curious. As usually on Mondays or once a week, we talk about what's in your backyard that you can see with a pair of binoculars, your own eyeballs. We know every backyard is light polluted. You're compromised to see even the Milky Way in your own backyard, but it's up there. And here we are, the first full day of autumn equinox. And if you're like Cliff Watson down in Australia, the first day of spring for you folks below the equator, and they're grateful for that. But it's getting to be sweater weather, but not down here in Florida, okay? So those of you enjoying the autumn season, this is kicking off now. Summer's over, but we're going to be talking about three stars that form a giant triangle over your head in your backyard. It's called the summer triangle, but it is really more prominent in the autumn skies when you don't have the high haze. September and October are the best months of the year for stargazing because the skies just seem to clear out a little bit from all that summer yuckiness. Skies are clear, and of course the temperature is wonderful to get out under the balm of the universe up there. So let's say hello to Marty Winkel, my producer over there, co-producer. Marty is not a very big stargazer, so you're a good barometer, Marty, if I'm connecting with people or not, understanding things. So, and we probably won't take any questions, folks, but we want to know that you're watching, and we're kicking off a wonderful week here at the American Space Museum. We got our energy going for the fall and ready to do great things for all of you space lovers on Stay Curious and in our memorabilia show coming up November 2nd, and then, of course, Shuttle Fest this spring. Well, autumn equinox happened on Sunday morning. This is the graphic that is a correct graphic. As you know, your second grade teacher, Miss Miller, had a globe on her desk that was tilted. It was not straight up and down because that is why we have the seasons. And oh, I forgot the graphic that William Whiting sent me, Marty. Doggone it, William, I went for that a couple times and didn't download that. And I'll show you that again. I'm going to do another show on Stay Curious. Most of the bodies of our solar system have been knocked over from spinning straight up and down, like this, spinning straight up and down. They're knocked over to their sides. And ours is 23.5 degrees. Mars is about 24.5 degrees. Something hit us and knocked us over. Something actually hit Venus and knocked it completely over, so it rotates backwards. All right, where we rotate kind of clockwise, looking up from the North Pole, it goes counterclockwise. So we're going to, and the reason why I point this out is I couldn't believe when I looked at Facebook posts yesterday that the National Weather Service posted on X that the fall autumnal equinox is today. But look, they've got the Earth is straight up and down and rotating at 0 degrees tilt. And that's not true, or 23.5 degrees tilt. And so I put this on our Facebook page, probably an AI generated graphic there. But this is why the tilt is the reason for the seasons. As I go back here, is we look at the sun is over on the other side 6 months from now. We're leaning into the sunlight, and therefore it's hotter. The analogy I like making, Marty, is at 9, 10 o'clock in the morning, the sun is definitely at an angle of like 30 degrees above the horizon. And that angle, the sunlight is not that hot, all right, because the sunlight is actually traveling further to hit your skin. But at 9 o'clock, or at midnight, at noon, noon to 3, that sun's directly overhead. The rays are more straight down. That means they're hotter instead of an angle of rays. So that's where you get a suntan. At 5 o'clock in the evening, you don't get a suntan. You feel the heat of the sun, but it's not as hot as it was because the angle is not as direct. So plain physics of light there. And I can't believe that the National Weather Society had this faux pas of showing the Earth rotating straight up and down instead of at an axis there. Well, also, Marty and other people telling me since last week that we're going to capture a new moon. The Earth is going to capture a new mini moon. This happens about every 2 or 3 years. We capture a renegade asteroid that's passing by Earth. This is a graphic I found to show you what does it mean it's going to get captured on the 29th of and this is the 23rd today of September. And then it's going to stay in Earth's orbit till the 25th, and then it returns to orbiting the sun. It'll be closest to Earth January 9th, 2025. This is what we're talking about. The Earth is moving through space. The object is moving through space. It occupies our gravitational pull for a while, but its momentum is such that it's going to be tossed out and away from us. Simulated mini-moon trajectory away from us there. And just to emphasize that there are thousands of near-Earth asteroids like this one that's in the news called 2024 PT5, all right? It's said to be our newest mini-moon. Well, look at all these objects that there's over 2,349 potentially hazardous astronauts on today's date that we're keeping track of from about, well, there you see the size. 9 meters is 27 feet. Up to 300 meters, it's about 1,000 feet. Yeah, Marty.
Not astronauts, asteroids.
Asteroids, okay, not astronauts. Welcome. Thank you, Marty. Can't remember what I say, I guess. But this chart shows you the date. September 17th is past. Down at the bottom is the 24th. The distance that it misses us, 2.6 LD, that is lunar diameters, all right? So you've got a couple, once in a while we have one inside the orbit of the moon, 240,000 miles away. That's their velocity, kilometers per second. And the diameter of these objects, you see in meters, they are not very small. It is not very big. It's incredible that we can see these objects from 50 feet easily up to, a quarter of a mile, all right? Well, this one we're talking about, this mini moon, PT5, is 30 feet across, all right? Like Marty and I were coming up with analogies, that's 3 first downs on a football field. It's 10 yards is 30 feet. Okay, that's that is 1 football field length, or 1 first down in football is 30 feet, 10 yards, all right? So think about that, or halfway to the pitcher's mound, you baseball fans, is which the baseball mound is 66 feet, Marty says, from the batter's box. So there, let me go back there to the Earth captures the mini moon there. And this is one in 1999 that came close to us. Now that's not a photo, that is a radar image taken, a radar photo as they scan these objects. It's so incredible how on Earth they tie together telescopes around the world and radio telescopes, and that makes it sort of a bigger receiver, and we can track all these things. So, but it's not going to be if, it's going to be when something hits the Earth that comes completely out of the blue that we don't see. But we see thousands of objects as demonstrated by this chart here that is every day on spaceweather.com. They update where are the close asteroids that could hit the Earth. Now, none of them there on the LD, that's lunar diameter. One is 7.2 lunar diameters. Once a month, one slips inside the diameter of the moon. I mean, lunar distance. It's not diameter. Lunar distance is 250,000 miles on the average. So a couple times we've had asteroids that have slipped underneath the geosynchronous orbit satellites, which are 22,000 miles up. Then you start getting a little hairy about, will gravity pull that in and hit us or not? So, So not to worry, we get these mini moons a couple times a decade, if not every other year now, as we see the smaller objects whizzing by. They're captured for a while and then they're ejected out of our out of our Earth's gravity. Well, on this date, September 26th, 23rd, 1846, the planet Neptune was discovered. By some calculations, Marty, thank you for clipping this out of your newspaper. An astronomer named John Gottfried Galle observed Neptune for the first time at the Berlin Observatory, all right, confirming the existence of the eighth planet of our solar system, all right, coming 178 years ago. Of course, Neptune is the furthest planet from the sun, as Pluto's been relegated to a dwarf planet. This was found by, again, gravity affecting the planet Uranus that was discovered about 100 years before. So it was based on mathematical calculations by a German and a British mathematicians, and Galle was the first one to see it. That same night, another amateur astronomer, or another professional astronomer, also saw it. Neptune is the most distant planet, 2 billion miles away. Light takes 4 hours to reach us from Neptune, traveling 186,000 miles a second. It's 30,000 miles across, about the same size as Uranus. These are gas ice giants. We know that inside of them is a lot of water, ice crystals. The compression of this 30,000 mile globe down could even have diamonds in a layer of its interior there. In fact, scientists have suspected for over 40 years that the crushing atmosphere of Uranus and Neptune would create diamonds. Now, this is a photograph, the best we have, from Voyager 2 spacecraft that flew by it in 1989. We celebrate that every August, and that is a dark spot like the red spot on Jupiter, and these white features of cloud tops. We're looking at the cloud tops of this planet. It is 350 degrees below zero on those cloud tops, named after the Roman god of the sea, Neptune. It takes 165 years to orbit the Earth, the sun once, so it's just completed one orbit since it's been discovered. To look through your backyard telescope, you would see Saturn and Jupiter like this in a 3-inch refractor or an 8-inch reflector, and that's how the best shot you get at Neptune right there, Marty. It would look like a distinct greenish disk there. Though that's a little bit blurred there, it looks like on this. These are 3 different photos put together to show you how tiny 4 billion miles away Jupiter looks. Neptune. Now, Uranus is, Jupiter is about 800 million miles away, and it's 80,000 miles across. Saturn is about a little over 1.25 billion miles away. And then you have Uranus and Neptune. And so Uranus is, its rings are the distance from the Earth to the moon there. So very, very small in the telescope. I've only seen it a handful of times, and usually in somebody's big professional telescope at a star party, and they got the computer that just locks in on it on there. So interesting that here's the 3 views of Jupiter that we have, of Neptune. Focus mark here. 3 views of Neptune we have: Voyager 2 in 1989, Hubble in 2021, and the Webb telescope last year took this picture. The Webb sees infrared, all right, so it's detecting heat. It also is detecting heat off of very cold features there, and among those features are the rings. There's 6 rings that orbit Neptune. Uranus also has rings, as well as Jupiter and Saturn. Saturn's rings we see from Earth. The others are like ropey, incomplete rings on some of them. So now you know about Neptune being discovered. By the way, its moon Triton is one of the largest in the solar system and has active geysers on it. So that's very interesting. Well, as we move on to look up at the night sky, humanity is slowly losing access to the night sky, and astronomers have invented a new term to describe the pain associated with the loss of even seeing the Milky Way from your own backyard. And that term is noctalgia, meaning sky grief, a real word, a real condition, actually. Here you see what we call the Bortle light scale. On the far left is the darkest skies you can get, and then of course above my head, cities, you're not going to see anything. But this just sort of shows you how in the suburbs, like right here in the middle, you look up, you can barely see the Milky Way that you would see in more rural areas there on the left. You know, this is a condition that just isn't an esoteric problem of making us feel good by looking at stars. This is a big deal to the natural world. We are now finding out that the light pollution of parking lots, and there's so many things that are lit up, from stores to parking lots to car sales areas, just everything's lit up in the night, and the animal world is being confused by it. Some creatures need to see the stars to navigate by. They truly do. Things like turtles that we know are nocturnal, and return to the sea that we protect here after they put their eggs on Cocoa Beach and Cape Canaveral Beach. You can see them out there all the time. They go towards light, okay, and that's why they want to dim the light around the beaches, because they don't want them going out in the roads. You go up to Cocoa Beach, Marty, if you hadn't been to the pier there, it's all red light at night, just like astronomers would love it, because red light does not hurt your eyesight and make your eyes contract after they dilate. So noctalgia is a real thing, and we're going to talk about sky grief here in a little bit. We're going to talk about 3 stars that we want you to see in your nighttime sky, real bright ones. We also want you to talk like an astronomer. And we're going to talk about the Milky Way. Going to show you some pictures of the Milky Way, the 3 stars that girdle the Milky Way that are so bright, easy to see in light polluted skies. To talk like an amateur astronomer, Marty, today is a 21-day-old moon. So it is, there you see the 21, it is at last quarter. And last quarter moon rises around midnight, all right? The full moon is 14 days old in the 29.5-day-old phases of the moon. So 14-day-old moon is full moon, and that rises when the sun sets. So 7 days later, the moon is rising about midnight. A quarter of it is seen, or half of it's seen. We should call it half moon, really. I don't know where the first quarter came from. The backside, the 3 other quarters that we don't see. So to talk like an amateur astronomer, today's 21 days old, and I'm saying, oh, wow, Marty, I can get outside and see the Milky Way tonight until after midnight, when this moon will be high up and start washing it out. The Milky Way is right there in the middle, in between this triangle called the Summer Triangle. And believe it or not, yes, the Summer Triangle rises in late spring, but now is really one of the best times to see the Milky Way and the Summer Triangle, as we call it. It is not a constellation. The Summer Triangle is a group of stars, and we're going to talk about that here. It's an asterism, all right? There's 88 official constellations, and then there's a handful of what we call asterisms. The Summer Triangle, the Big Dipper is an asterism. It's just part of the constellation Ursa Major, the Big Bear. So first, we got to talk a lot of current events here, because who's orbiting Earth? We just had an exciting event happen this morning where the crew of the International Space Station was reduced by 3 people as the Soyuz MS-25 with Oleg Konyenko and Nikolai Chubb landed with NASA astronaut Tracy Dyson. All right. now there's 12 humans in space, 9 on the ISS and 3 on the Chinese Tiangong space station. There, left to right, is Chubb, and in the middle is Konyenko, and there's Tracy Dyson, Caldwell Dyson. You remember her on NASA channel. She did Station Life, so perky, so happy she got to go to space after waiting 12 years. Tyson is just now 1 day short of tying Chubb's single mission tally. She's got 375 days. He's got 374. She's got 373 days. Konyenko, though, landed on his 1,111th day in space. Wow, you can't make that up. 4 aces there. Over 5 missions. He is the first person in history to exceed 1,000 days off the Earth. Previously, it was 878 days, logged by another Russian in 2015. 184 days they stayed up on the International Space Station. And hope maybe Tracy will go back to space again. But there they are talking. She's on the phone there, no doubt, talking to NASA friends already. 12 humans orbiting the Earth. We've got the Crew Dragon there, okay? Crew 8. They're going to come back a week from Friday, Marty. October 4th is scheduled to come back. You've got then staying up till February will be the crew of MS 2026 there. That includes American Don Pennant and 2 Russians. And then you've got the Starliner abandoned crew, Sonny Williams and Butch Wilmer are going to stay up there till February, all right, with Expedition 72 that's going to be launched hopefully Thursday. Get to that in a second. As far as the Russians, the Chinese there, they're going to stay up until November when they're swapped out. They've been up there about 5 months also. So I've got the Dragon 8 crew has been up there 205 days. Butch and Sonny been up there 112 days on their 8-day promised trip. And Soyuz MS-26 has been up there 2 weeks now. Of their 6-month ISS mission that will segue into the 72nd expedition crew up there. So yes, we're going to look for a launch Thursday, but don't hold your breath. That is Nick Hague and Alexander Gorbanov, both experienced astronauts. So they're on crew 9 of the Dragon. Thank you for giving us these pictures. Carlton Bailey was out there photographing their arrival. I think it was yesterday. And they're scheduled to launch Thursday, so they're in quarantine. Of course, there's going to be Carmen Zeman and Stephanie Wilson were going to accompany these 2 gentlemen to space station. But they got scratched so they could bring back Butch and Sonny in February. Don't know when they're going to be put into another crew rotation. Those 2 ladies, Zena Cardman, a rookie, and 3-time shuttle Stephanie Wilson. But they're going to go up Thursday. Weather's supposed to be crazy on the Gulf of Mexico. A hurricane hitting in our little elbow up there. But so I don't know what's going to happen here, but we'll be watching to see if they get launched about 2 in the afternoon, a daytime afternoon launch. So hope weather's good. All they need is just an open window to get through up there to space. So and there's another picture Carlton Bailey took for us there. Look at the 72 patch, the first time I've seen it. Just a simple 72 in the International Space Station. Is all they're going with on that insignia there. So good luck to them, and continued occupation of the International Space Station will continue as it has for over 22 years. Got a happy birthday here, Marty. Somebody that you know pretty well. Lauren Shriver's 80th birthday is today. Born in Jefferson, Iowa on September 23rd, 1944. A marathon runner, he carried the 1996 Olympic flame onto the property of Kennedy Space Center. Marty also enjoyed doing something He helped light the cauldron with the Olympic torch there. And like I said, an Iowa native, 3 space flights, 16 days in space, once a pilot, twice a commander. He deployed the Hubble telescope, and an early astronaut, of course. He was involved with the United Space Alliance until the end of the shuttle program in his retirement. There's a picture of Lauren, a famous picture of him in space eating Skittles, I believe, or chocolate, or what do they call it, candy coated chocolates, which are M&Ms.
Skittles.
Those M&Ms?
Skittles.
Yeah, Skittles. Okay. And you actually ran with Lauren, didn't you, Marty?
Yes, at times. Yeah.
The marathon runner, beat the boss. Was he part of that too?
Yeah, he was one of my runners that beat the boss.
Yeah, cool. Great guy, right? I'm sure we'd love to see him on the Space Coast here. So, all right, that's taking care of a little bit of business there. We're gonna look at the Milky Way. All right, there you see the Milky Way in an artist's conception. See where the sun is? We're so insignificant. This is 100 billion with the B stars. All right. We think that most stars have planets going around them. So that means when you see all these stars in the sky, there's 3 times as many planets going around them. And everybody knows the 3 parts of the Milky Way, right, Marty? Caramel, chocolate, and nougat. If you don't know that, then you've not been watching Stay Star Curious. We're going to talk about these 3 stars, Deneb, Vega, and Altair. And I'm promising you, you go out on your backyard in the twilight when it gets dark, you're going to look overhead. You're going to face the east where the sun's set. These 3 stars are going to be very visible until late November, even in December. Vega will be still bright above the horizon on Christmas night for about an hour. But those called the summer triangle, it's really moving over. It looks so spectacular when it's on the western side of the sky. And our September and October skies have cleared with those crystal clear skies that autumn always brings us. So we're talking about 3 constellations. Cygnus the swan on the left. You see it looks like a cross, or the arms of the swan. Deneb is actually the tail. It means tail in Arabic, all right? So the head is in the star in the middle of the triangle, and that is a beautiful star. That's the one I was looking at, pretending to look at through my binoculars, Albireo. It is so striking, the blue and the gold, you can't miss it, even with binoculars, but you need binoculars. Then Vega is part of Lyra, the harp. Lyra is the name the Greeks had for a harp. And lyre, okay, was a musical instrument, small little handheld harp. And it looks like a bent parallelogram there. And then Altair is in Aquila the eagle, which is a smaller cross in the sky that looks like, again, arms, stars make the arms and then the body by other stars, so it looks like a mini cross. By the way, Cygnus is also called the Northern Cross because it looks so distinctive like a cross. And that together they make a triangle in the sky. There's also a winter triangle in the sky, okay? But each star is unique in size, distance, and energy output. You're not going to believe what the energy output of one of these stars would do if we swapped these stars around. I want to emphasize that stars are like people. There's different sizes, even different shapes, okay? And their distances sometimes dictates how bright they are. The brighter stars truly are the closest stars to our sun, all right? But there's a couple stars that are just powerhouses that you can't believe. And one of them is Deneb here. So let's look at these stars the way we perceive them in the sky. There's a chart of a astronomical chart showing them again. And here's the beautiful stars photographed in a telescope. Now, a backyard telescope, any star is just going to look like a point of light. And the longer you expose it, the more. But this is their backdrop in the Milky Way. Look at all the stars behind them in the Milky Way that are millions of light years away. Well, these are very close stars to us, okay? Let's first look at Deneb in the middle there. Here's all three of them. But that is Deneb in the sun. This is a to-scale drawing of what they would look like to scale. Deneb is so gigantic, it is called a white super giant star. It would swallow up Venus in orbiting our sun if it was put where our sun is. All right, Deneb on the bottom there. Vega and Altair are a lot larger than our sun. In fact, our sun is actually called a dwarf star. It is not a very big star at all. It is really one of in the smaller classes of stars up there. Deneb puts out 70,000 times more sun, more powerful than the sun, 70,000 times. It's one of the most powerful stars in the sky. It is 800 light years away. All right. Now Vega is only 26 light years away. Up there in the upper left, and yes, it appears to be oblong shaped in the Webb telescope, the Hubble telescope, these gigantic interferometer telescopes where they put one together in Brazil and Arizona and on Mauna Kea and Hawaii and act like that's the baseline. They can do that now. They're seeing shapes to stars and even sunspots or star spots suspected on other stars. Well, if we swapped Deneb and Altair in the sky, Deneb would cast a shadow in the daytime. All right, it would illuminate. You'd be able to read at night under it. It'd be like the full moonlight on there. But so be glad that it's 1,800 light years away and not as close as Altair or Altair and Aquila or Vega is. That's why Vega looks so bright. There again, looking at the cross of Cygnus the Swan, the northern cross, there's Deneb, which means hind quarters or rear end, basically. Alberio means beak. All right, Alberio is a word that means beak in Arabic, like beak of the swan. And Alberio is the one I was telling you to look at through with binoculars, because it'll look similar to this in a photograph somebody took. All right, and what they do is they put a filter over their camera to enlarge the stars into a blob so you can see the light. But it looks very much like that in a pair of binoculars or a small telescope. Gold and blue azure. Alberio, the best color combination in the sky, and you'll have till late November to see it. There again, the triangle. All right, and we're looking at going up to Vega at the top over there. Vega in the summer evenings there. Vega in the Earth in comparison, we think that it's oblate spheroid because it's spinning so fast. Vega is a brilliant bluish star, one of the closest to Earth, just 26 light years away. So the light we're looking at Vega tonight left in 1998. Traveling at 6 trillion miles an hour, it took 26 years to hit our eyes tonight. The sun is moving in the direction of Vega, and in 50,000 years, it will be visible in the daytime. It will be so much brighter as we're closer to it. And Vega was the pole star 12,000 years ago. That's right, the North Pole moves around, all right. As you see at the top is Polaris, okay, and the actual, it's this far off the in the center there is the movement of the North Celestial Pole in what we call precession of the equinoxes. All right, precession, the Earth is actually wobbling as we move it. We're spinning, but we're also wobbling like a top. It's losing energy. So Polaris, the year 2000, that's what that means. You see over here Vega, 14,000 AD. It will be the North's closest star. So we're lucky to have a pretty bright star, Thuban. You see in the upper right, hands of a clock could be like about 2 o'clock. 2,000 years ago, Thuban was the star that was our axis pointed to. Well, there's the parallelogram of Lyra the Harp. That's pretty easy to see. Those are 4 pretty bright stars that you can pick out with Vega. In the middle of the bottom 2 parallelogram stars is M57, Messier's amateur astronomer catalog number 57 on there. And that is the Ring Nebula, or the Smoke Ring Nebula. All right. Famous object that we all find when we're cutting our teeth in our backyard with a telescope. It looks so wispy and so cool like that, very small, pretty much like that in a good backyard telescope. But to the Hubble telescope, it actually looks like the star in the center, blew up and its outer shell exploded. And though it's not so much of a sphere, Marty, it's actually like looking through a short toilet paper tube. We all know what those are like. It's more of a cylinder explosion than a ball explosion for some reason. But one of the most photographed and sought after objects in the sky. By the way, as we get back to Vega, was the first star photographed through a telescope in 1850 at Harvard University. About the size of the sun, it's 50 times more powerful. There is the beautiful Ring Nebula, and there's another photograph of it through the Hubble through a series of different telescopes, showing you the complexities that's seen in hydrogen light versus visible light. So a lot of unseen things to our visual spectrum that is so narrow of what is in the electromagnetic spectrum of what's going on in our universe. All right, we're going from there, and there you got again to the final star we want to talk about is Altair in Aquila the Eagle. All right, closest of the summer triangle stars. It is 17 light years away. All right, Deneb is 1,800 light years away. Vega is 26, but Altair is a very close 17 light years away. The light left in 2007 that we're looking at right now. So slightly larger than the sun. It spins every 7 hours compared to 25 days for our sun. Altair may look squashed, twice as wide as it is tall because it spins so fast. All right. And it's one of the first stars looked at by the Webb telescope. They're trying to determine, this is not a Webb telescope, but it's a rendition of artist concept of what they think. This is a Webb telescope image taken of the star. They put on the rotational axis and stuff as the orientation from the Earth. So isn't that fascinating that stars have different shapes, different sizes? There is the size comparison of the Earth and Altair in Aquila the Eagle. All right, Altair is may have star spots on it like that. If our sun has it, why not? Why wouldn't other objects in the solar system have it? So there you go. Get out in your backyard, look up at the summer triangle in the autumn. You'll see it, the 3 stars. Get you a star map so you can sketch out things on there. Thank you all for watching today. I know that, let's go here, see what I got next. The image here. There's the comparison of these 3 beautiful stars there, and hope that you can get out under the sky to see these beautiful stars. All right. Dave Stangy's up in Michigan. Thank you for watching, Dave. Carlton Bailey, thank you for your photographs. Here's the Milky Way out at Herky Huffman Park, and that up in the left-hand corner, that's a firefly. They interrupted my 30-second exposure. But that's what I'm hoping to see is some Milky Way this weekend, and next weekend will be excellent. In fact, the next 3 weekends. Haven't seen it much this summer because it's just been too rainy and cloudy around here. And Mark Usiak, you're in Pennsylvania. Hope you have clear skies. Steve Jokums, thank you, sir, for watching today. Doug Forrest, Clyde Lewis, my daughter, Jessie McKinley. Jessie McKinley and Macy are watching there. So hope you guys got a little star knowledge there, and hope to see you all soon. Gary Gerald's watching in Georgia. Tommy Usiak in Pennsylvania. Dr. Keith Sowell, I'll be responding to you, Keith, here later today. And Mitch Rothman is watching from Scotland. Thank you, Mitch. Hope you're having a great trip with your wife there. Again, another hello to my granddaughter, McKinley and Macy. Yeah, Marty.
Cliff Hudson.
Oh, Cliff Watson, first day of spring for you, Cliff. I know you're digging that down there in Pomona, Australia, as he's waking up to his Tuesday brekkie. So thank you all for watching today. We're lining up some guests for the next 2 weeks. Got a very interesting lady that has written a book, a kid's book that you're going to enjoy her on Thursday, and we're lining up our regular group here for the end of this month and the beginning of October. So thank you all for watching. Until next time, thank you, Marty, for a great job. I'm Marquette saying, keep looking up, get under those stars, all right, and get in our museum or watch Stay Curious so we can bridge the space between us. See ya, grandkids.